Back to the Comptia Network Plus course. File hashing. Another security feature that can be utilised to prevent issues caused when malware attempts to alter or delete system files is file hashing. A hash function takes a message of variable length and produces a fixed length hash value. Hash values, also referred to as message digests, are calculated using the original message. If the receiver calculates a hash value that is the same as the hash value of the original message is intact. If the receiver calculates that the hash value is different, then the original message was altered. Using a given function h, the following equation must be true to ensure that the original message M1 has not been altered or replaced with a new message M2H, M1H, M2 by using software that computes the hash values for all systems files and continually verifying these values, you can detect changes to system files. Generating new keys. Devices can use keys which are long, randomly generated character streams as input to encryption algorithms when encrypting data either in transit or at rest. At specified intervals, these keys must be renewed. While it is possible to renew the use of the key or key pair, generating a new key or key pair is advised. The longer a key is in use, the more likely the key will be compromised. Generating new keys at renewal time increases security. Upgrading and downgrading. Whenever a new version of an operating system or application is released, it usually generates a debate over whether the upgrade should be implemented. This is because experience has taught many IT technicians that there are often problems with a new release that they would prefer to avoid until someone else locates and corrects them. Waiting until all the bugs are ironed out in an upgraded release is probably not a bad idea unless the upgrade addresses a security issue. In those cases, the risk is probably worth taking to close the security hole. In some cases, it may be necessary to reverse or downgrade a system to the old version if the new version causes substantial issues in the production environment. You can save yourself a lot of grief and possible downtime in the production environment by telling all new versions of applications, operating systems and firmware before deploying them. Asset disposal. When the time comes to decommission an asset such as a server or a hard drive, the handling of any data that remains is a big security issue. Whenever the data is erased or removed from a storage media, residual data can be left behind. This can allow data to be reconstructed when the organization disposes of the media, resulting in unauthorized individuals or groups gaining access to data. Media that security professionals must consider include magnetic hard drives, solid-state hard drives, magnetic tapes, optical media such as CDs and DVDs. When considering data remnants, security professionals must understand three countermeasures: clearing, purging and destruction. Clearing includes removing data from the media so that the data cannot be reconstructed using normal file recovery techniques and tools. With this method, the data is only recoverable using special forensic techniques. Purging, also referred to as sanitation, makes the data unreadable even with advanced forensic techniques. With this technique, data should be unrecoverable. Destruction involves destroying the media on which the data resides. Overwriting is the destruction of data that writes patterns over the entire media, thereby eliminating any data trace. Degaussing, another destruction technique, exposes the media to a powerful alternating magnetic field, removing any previously written data and leaving the media in a magnetically randomized blank state. Encryption scrambles the data on the media, thereby rendering it unreadable without the encryption key. Physical destruction involves physically breaking the media apart or chemically altering it. For magnetic media, physical destruction can also involve exposure to high temperatures. Most of the countermeasures given work for magnetic media. However, solid-state drives present unique challenges because they cannot be overwritten. Most solid-state drive vendors provide sanitation commands that can be used to erase data on the drive. Security professionals should research these commands to ensure they are effective. Another option for these drives is to erase the cryptographic key. Often a combination of these methods must be used to fully ensure that the data is removed. Data remnants is also a consideration when using any cloud-based solution for an organization. Security professionals should work with their organization when negotiating any contract with a cloud-based provider to ensure that the contract recovers data remnants issues. Although it is difficult to determine that the data is properly removed, using data encryption is a great way to ensure that data remnants is not a concern when dealing with the cloud. Detection. Certain devices and features they offer can help us to detect when something is awry. Technicians should make use of these tools and features to apprise themselves of issues that require their attention. Motion detection. In areas that require constant attention to security, it may be advisable to install motion detectors of some sort. Server rooms, wiring closets and other critical areas may need these. Let's take a look at another few. Infrared sensors. Passive infrared sensors, PIR, operating by identifying changes in heat waves in an area. Because the presence of an intruder would raise the temperature of surrounding air particles, the system alerts or sounds the alarm when this occurs. Electromagnetic systems. Electromagnetic systems operate by detecting a break in an electrical circuit. For example, the circuit might cross a window or door. When a window or door is opened, the circuit is broken, setting off an alert of some sort. Another example might be a pressure pad placed under the carpet to detect the presence of individuals. Photoelectric systems. Photoelectric systems operate by detecting changes in the light and thus are used in windowless areas. They send a beam of light across the area, and if the beam is interrupted by a person, for example, the alarm is triggered. Acoustical detection systems. Acoustical systems use strategically placed microphones to detect any sound made during a forced entry. These systems only work well in areas where there is not a lot of surrounding noise. They are typically very sensitive, which would cause many false alarms in a loud area, such as a door next to a busy street. Wave motion detector. These devices generate a wave pattern in an area and detect any motion that disturbs the wave pattern. When the wave pattern is disturbed, an alarm sounds. Capacitance Detector. These devices emit a magnetic field and monitor the field. If the field is disrupted, which will occur when a person enters the area, the alarm will sound. Asset tracking tags. Proper asset management is not rocket science. It boils down to knowing exactly what you have, when you got it, where it is, and where the license to use it is. The devil, as they say, is in the details. Most server administrators don't set out to intentionally exercise poor asset management. They simply don't give the importance it requires to be done correctly. Labeling or tagging servers, workstations, printers, ports on infrastructure devices, routers and switches and other items is another form of asset documentation that often doesn't receive enough attention. Not only does it make your day-to-day duties easier, it makes the process of maintaining accurate records simpler and supports a proper asset management plan. When periodic inventories are taken, you are doing that right. Having these items labelled makes the process so much quicker. This goes for cables in the server room as well. Tamper detection. Tamper detection refers to any method that alerts you when a device or the enclosure in which it resides has been opened or an attempt has been made to open it. A good example is chassis intrusion detection. You should use settings in the BIOS to alert you when the case has been opened. These settings are shown in figure 14.14. In this case, the open case warning has not been enabled yet. Anti-malware software. Of all the update types that need to be maintained, anti-malware updates are the most critical to the organization. You must maintain updates to the malware definitions as well as updates to the malware engine itself. When choosing an anti-malware solution, there are two approaches: host-based, also called premise-based, and cloud-based. In the following sections we'll examine both. Host-based or on-premise based anti-malware is a solution that you install and run inside your network. It has the advantage of giving you total control over the process, but also requires you to stay on top of updates. It also requires the deployment of some hardware to hold the engine and the definition files. Cloud server-based. Cloud antivirus products run not on local computers but in the cloud, creating a smaller footprint on the client and utilizing processing power in the cloud. They have the following advantages. They allow access to the latest malware data within minutes of the cloud antivirus service learning about it. They eliminate the need to continually upgrade your antivirus software. The client is small and it requires little processing power. Cloud antivirus products have the following disadvantages. There is a client to cloud relationship, which means they cannot run in the background. They may scan only the core Windows files for viruses and not the whole computer. They are highly dependent on an internet connection. Configuring backups. We create device configurations over time that can be quite complicated, and in some cases where multiple technicians have played a role, no single person has a complete understanding of the configuration. For this reason, configurations should be backed up. Configurations may sometimes exist as text files, such as in a router or switch. Other times, such as with a Microsoft server, you will back up what is called the system state. This backs up only the configuration of the server and not the data. In this case, a system state backup and data backup should be performed. It is also possible to back up the entire computer, which it would include both data sets. Considering the time it takes to set up a new device, installing the operating system and reconfiguring to replace a defective device, it makes great sense to keep backups of configurations so that if a device fails, you can quickly re-image a new machine and simply apply the system state to it or apply the configuration file in the case of routers and switches. So I'm going to leave it here today for this video. If you like listening, please give me a thumbs up, like, share and subscribe. Thank you.